Hello everyone, today we're going to be going over the 2026 FECOS MA exam problem 11. Now first, the physics joke of the video is, why was the physics book so stressed? Because it had too many problems. Okay. Now let's get back to the problem. So this problem is about momentum and energy. So let's start by reading it. A circular track of mass m, so I'm going to draw this, mass m, lies flat horizontally on a frictionless table and is free to move on it. A bead, also of mass m, so I'm going to draw that this bead is mass m, can slide without friction on the track. The track is initially at rest, and it's labeled every 45 degrees with tick marks. The bead is placed on tick 1 and is given an initial velocity v0 tangential to the track as shown below. What is the speed of the track center O when the bead reaches tick 3? Okay. So, let me zoom in on this. So first of all, we know that there's no friction, right? So that means that energy is conserved, okay? And there's no mention of inelastic collisions or anything, and because of energy conservation, momentum is also conserved, okay? So we can start by listing, so we have to give some variables, right, for these. So first of all, we already know that the velocity of this is v0 at the start, and at the end, this bead travels to 3, right? Now at 3, the bead has a velocity, we're not sure, maybe it's this way, but anyways, the bead has a velocity, right? And we're gonna call it v, vb, how about that? And for this track, we're gonna call it vt. So we have vb and vt. Now, first of all, for energy conservation, so E initial equals E final. And it's only kinetic energy, so E initial is going to be 1/2 m times v naught squared, because initially there's only this that's moving. And it's going to be equal to 1/2 m v bead squared plus 1/2 m v track squared. Okay, and since they have the same mass, these get canceled out. And so v naught squared equals vb squared plus vt squared. Okay, so after we have this, we want to have a momentum conservation in the x direction and y direction. Okay, so we know that mv squared, mv naught, because that's the initial momentum, is equal to the final momentum, which is, so now this is the part where we want to split our velocities into components, because this vb, it could be traveling this way, so we don't know the specific angle, but we know that there's this part of it that's vbx, and this is vby, okay? And we can do the same thing of v track, sorry, I'm going to draw it here. So then there's this v track x, and there's also a v track y. So mv naught is going to be equal to m times v, so vbx, right? Plus m times vtx. And the y momentum is initially 0. It's going to be equal to, It's going to be equal to vbx, vby plus vty. So that means one of them has to be negative. Okay. And yeah, I just labeled them in these directions just because it doesn't matter, because if it's negative, it's just the opposite direction. Yeah. So now we can use the Pythagorean theorem, right? VB squared is equal to VBY squared plus VBX squared. So then we can further simplify this, expand this into VBX squared plus VBY squared plus VTX squared plus VTY squared. And after this, we can, use another constraint. So, think about when the bead approaches this point, right? Because of the track, it is constrained to moving in this direction relative to the track. So we know that at this point, VBX and VTX are equal, okay? So track shows that VBX is equal to VTX. And then we can plug it into here. So first of all, we can cancel all the m's in this equation. V naught is equal to VBX plus VTX, which is just 2 times VBX. So VBX is equal to V naught over 2. Okay, so, and that is also equal to VTX. So, let's add this. V naught squared equals to VBX, which is V naught over 2 squared. It's going to be equal to V naught squared over 4 plus VBY squared plus VTX squared, which is also V naught over 4. So I'm just going to multiply this by 2, which gives V naught squared over 2, and plus VTY squared. Now VBY plus VTY is going to be equal to 0. But how about this squared? So that's going to be different. Now, if we try to square this, we'll end up with a term that's 2 VBY VTY. So, we'll have to think about something better. So, well, we know that we have momentum and energy, right? So we can try to incorporate this equation into here. So, well, what if we try to write one of them in the other? So we can say that VBY is equal to negative VTY, okay? So then V naught squared is equal to V naught squared minus V naught squared over 2, which is just V naught squared over 2, is equal to VBY squared plus, so basically plus VTY squared. Because, because VBY equals negative VTY, then it's just equal to 2 VBYs. So VBY squared times 2 is going to be equal to V naught squared over 2. And divide both sides by 2, we get this. And after we square both sides, VBY is equal to V naught over 2. Okay. So, we got this. We got, this. So now we just need to, let's see. So it's asking the speed of the track center O. Now that's going to be VTX, VTY. So it's going to be the square root of VTX squared plus VTY squared, which is equal to the square root of, now what's VTX? It's V naught over 2, right? V naught over 2 squared plus VTY, and VTY is just negative VBY, which is negative V naught over 2, but we can square it to get V naught over 2 squared, because this negative times negative equals positive, and that gives 2 times V naught squared over 4, which is equal to the square root of V naught squared over 2, which is equal to V naught over square root 2. So that's going to be our answer choice, D. Thank you for watching. If you have any questions, please ask them in the comments, and make sure to like and subscribe. Thank you.